So with this angle sheet, there's quite a lot of difficult angles around, but there are quite a lot of things that are linked as well. So the things that are linked, for example, will be that these three lines here are going to be parallel, and we know that these two lines are parallel, and so is that one actually. There are three parallel lines there, and we've got a third set of parallel lines here. Notice also we've got two line dashes here, which mean they are the same length. That would mean that this is an isosceles triangle, but we'll get to that in a minute. We have to make one assumption here. If this is a right angle and this is a right angle, this could be a right angle trapezium overall. Now we have to assume that it's not. We have to assume that this is rectangular. So this would also be 90 degrees. Now if this is 20 degrees, that would make this one here 70 degrees. So that could be one first assumption that we could make. From the Z rule, or the alternate angle rule, we know that this is also 70. And that makes sense, really, because this is a triangle. The angles here would have to add up to 180 degrees, and they do. Also, if that's 70, then this must be 70. This is an F angle, also just a corresponding angle here. How else could we incorporate 70 degrees? Well, it's on this side as well. So this would be 70. Still, we haven't really got anywhere with R in terms of A, B, and C. But we can find X here actually quite simply. If we know that this whole angle here is 180 degrees, and that's 3x, then each x must be 60 degrees. So this would be 120 degrees, and this would be 60. And then in this small triangle, we notice that A must be 50 degrees, because they must all add up to 180. So from that we can say that A is 50 degrees. Now if that's 50, 2A, this angle here, must be 100 degrees. And I'm scanning around here for any more A's, and there's one here. So this should be 100 degrees as well. Now the next thing is to notice that the how else we can use any of these angles. So let's focus on this side actually. If we know that this is the same split as above, then this is like a bow tie, right? So if that's 60 degrees, then this should also be 60 degrees. If this is 120 degrees, down here, that's also 120 degrees. And you see, we're just making our way around the grid. This hasn't really helped, but we may be able to incorporate our parallel lines here. So if this is 60 degrees, then hey, look, this one's also 60 degrees because of the corresponding F angle that we were talking about before, which would make this one 50 degrees because of the triangle here. Now, if this is 50 and this is 100, that means that this angle down here is going to be 30 degrees. And we're getting closer now to the angles down here. Now, the next angle we've got to find is B. So where is B on this diagram? It's here. So there should be a way of finding this angle out fairly quickly, but at the moment I can't see it. But maybe we can get to it from this angle here. So if this is 60, this is 100, this angle would be 20 degrees. And now with this triangle, we know that they add up to 80, so this must be 100 degrees. And notice that this shape here is a parallelogram, and opposite sides within a parallelogram are equal. So this here would be 60 degrees because this one is 60 degrees. And the one down here would be the same as 20 because of the Z angle here. That should be 20 degrees. And this will help us work out both B and C. So B must be 80 degrees because it's the remainder of 180 on this straight line. So I'll write that down here. This is 80 degrees. And C would be the remainder of 180 from 20, which would be 160 degrees. So now we've done A, B, and C. What about D? D lies here, here, and here. So we've got to try to somehow work out what D is. I think it's actually simpler to work out G at this stage, because we know that if this is parallel to this one, then if that's 50 degrees, then this must also be 50 degrees. And therefore this one down here would be 40 degrees. So we've actually worked out G a lot sooner than I expected. That's 40 degrees. Now, the internal angles here, how many sides have we got? 1, 2, 3, 4, 5, 6, 7. In a 7-sided shape, you have 5 triangles. And 5 triangles would give you a total internal angle of 5 times 180, which is 900 degrees. So inside this shape, there should be 900 degrees. Well, I can get this one. That would be 120. I don't know what this one is yet. And this one, I can't work that one out either at the moment. But I'm just looking to see where this line goes. This line goes over to this angle here. Now, can I work that one out, maybe? Yeah, I think I can. Actually, notice you've got a big triangle here. And I can work this angle out here. So that would be 110 degrees. And this is another 20 degrees, 130. So this one down here should be 50 degrees. Because of the triangle here, sort of hidden with these lines in between. And as I said before, now this is isosceles triangle, this would then be 50 degrees as well. Now 50 and 50 make 100, this would be 80 degrees. Now this is linking with this line now. This might be useful later on. So this would be 100 degrees. And this one, remainder 180 from 50, would be 130 degrees, which is the same as the one underneath, 130. And if that's 50, then this would also be 50 on this side here. Okay, we're moving down into D now. What about this angle? If I know that inside here I've got a quadrilateral, the total internal angle of the quadrilateral is 360. So maybe I can work this out. I've got 2 unknowns, so that might be a problem. What else can I find? I'm going to make a part 2 after I've given it some thought.